And we are live. Yep. Go ahead, Neil.
Good. Welcome to the Fab Academy recitation. And I'm delighted to have the CEO of SolidWorks, Paolo Bassi, joining us. There's this interesting kind of inversion. SolidWorks, it historically was aimed at professional engineers, but is used all over the maker world when people move from doing easy things to hard things. And more recently has been a great collaboration making SolidWorks available in Fab Academy and Fab Labs. The reason I'm delighted Paolo could join us is you've seen the present of what it is, but not the arc of what's in the pipeline and where it's heading. And so this is a great chance to see not just the present, but the arc of the future of SolidWorks. So with that, I'll mute but join and hand off to Paolo.
Okay, thank you. Good morning, good afternoon, everybody connected from all over the world. I'm very happy to be here. Thank you, Neil, for inviting me. So I go directly into the presentation because I wanted to be very efficient and mindful of the time that we are using here. I hope you please confirm you can see my screen. Okay.
Yes, that's fine.
Okay, very good. So let me go directly into the presentation with. Okay, so first of all, as a CEO, I cannot refrain from giving you a few numbers of which I'm very proud. So today we have sold about 3 million seats, and worldwide, globally, we have around 230,000 customers. This means that you know, the reach and the complexity of the problems that SolidWorks can solve is pretty wide. In addition to seats sold, we can say that an important indicator for us is the number of schools where SolidWorks is taught and also used in the research departments. Today there are about 30,000. We also support and maintain a certification program in order to make sure that there is some kind of standard in the industry for the skill level that is today required to master SolidWorks. As I said, for us, the education world is extremely important because education is where a lot of innovation happens and where the thinking is most looking forward for the most time. In fact, we are present in many student competitions. For instance, the formulas SAE all over the world. MIT, in addition to our collaboration with the Center of Bit and Atoms, SolidWorks was used for the SpaceX competition as the Hyperloop that the team won last year in the Netherlands, I understand, and many other challenging activities and competition happening all over the world. In particular, robotics. SolidWorks is used to develop humanoid robotics. This one is the winner of the DARPA challenge that came up after the Fukushima disaster in order to stimulate research and development of robots, humanoid robots, semi-autonomous robots that would be able to operate in disaster zones. And this was the one developed by the Jet Propulsion Laboratories. There were about 13 finalists there. Most of them used the SolidWorks. And speaking of natural disasters, you all probably remember the story of the miners trapped in Chile in 2010. Probably not everybody knows that the device that was used to find and eventually free the miners was designed with the SolidWorks in a very rapid design cycles. They had a lot of issues. They had to use simulation, flow simulation. Let me show you a video that tells that story.
The rescue of 33 miners from the depths of a copper mine in Chile touched the world. What began as a catastrophic mining disaster became a story of hope, endurance, and technical ingenuity. As the world held its breath, an unprecedented rescue mission swung into action.
Brandon Fisher, the president of our company, heard on the news that the statements were that they felt the miners wouldn't get out until Christmas. He said, that's nuts, because we know we can drill a hole faster than that. So we made connections with people in Chile, put together a plan for what we proposed, which was Step 1 enlarged that 5.5-inch hole to 12 inches. Step 2 enlarged the 12-inch hole to 26 inches, and therefore large enough to put the rescue cask through. At about 1/3 of the total depth, or let's say 200 meters, ran into a problem. The drill stopped working. And when they pulled the drill string up out of the hole, we realized that the front end of the bit was missing. There had been speculation at the time that we'd hit a piece of iron in the mine. Remember, we're trying to zigzag our way around existing mine workings to hit this target that was underneath it. Not being convinced that that was the case, we started with a fairly in-depth analysis of the bit just to make sure that our stress levels were acceptable. So we used SolidWorks nonlinear FEA to actually simulate the impact of the piston on the bit and the reaction of the bit into the rock. And we satisfied ourselves that there wasn't an inherent problem there. I think the fact that the SolidWorks CAD software integrates so seamlessly with simulation just made that whole process go snap, snap. It also gave us the confidence up front to know that we could get it done. The next step was to open this hole from 12 to 26. One of the concerns we had was whether the airflow going through our drill would split appropriately. So we set up a simulation using flow simulation. Verified that we had to tweak our design a little bit to get more of the airflow biased towards the middle. Both of those are examples of how SolidWorks was used to perhaps increase the chances of us having a successful rescue of miners. From a business standpoint, I think I've created a lot of technology for the drilling industry that has made people money, maybe made their livelihoods better. In some cases, in extreme, saved lives. And I feel that I've put my passion into the business, and I think SolidWorks helps me do that too. It's an enabler.
Okay, so I like this video is very interesting. So in addition to education, we are adopted by a lot of startups. We are very close to the incubators world. We are very close to the makers movement. We like it a lot. We are very much inspired, and we are proud to share with you the success stories of many young entrepreneurs. This is one of them, a UK student that designed a simple and cute device to hold your cell phone at the same time, the earbuds, all in one. It's very cool. This one is interesting one, an inflatable incubator for developing countries. A lot of startups are working on medical devices designed for the third world. This is very interesting. This is a maker creating tools for makers. The Glowforge 2D laser cutting designed in SolidWorks, and they raised like $30 million in 30 days. They set a new record in crowdfunding as a Kickstarter. This is another one to measure the impact and the solicitations on a helmet and so on. So we can say that SolidWorks is everywhere. As a matter of fact, we have a Twitter hashtag that we like to use when we tweet. And among the many places where SolidWorks is found, the latest one I was part of was a Rwanda inauguration of a Fab Lab. So this is the first Fab Lab place in, I think, Central Africa, in the city of Kigali in Rwanda. And I have some pictures here with you, with Neil as well, and some people from both the Center of Bit and Atoms and SolidWorks. We had a lot of fun using the devices ourselves. I think we need to all eat our dog food, as we say, and we experimented with fabricating. I worked with a colleague of mine, Suchit, to create this little ring, and we did it from art to part. So we designed it with SolidWorks, and we created a 3D print. We created a cast around the 3D print, and the cast, surprisingly, was a silicon, was a rubber type of material. I couldn't believe that you could pour liquid metal into such a thing, but it worked perfectly. And we cast about a dozen of rings that went away, immediately. People loved this demonstration of how everybody can make almost anything. And we also had the honor to be received by the president of Rwanda, Paul Kagame, with whom we spent about half an hour. He was very grateful of us helping his country propel into the future, and probably stepping over many of the traditional steps of the evolution of countries, and possibly avoiding many mistakes that we all did in the past couple of centuries. So the mission, what we do is basically design. We are totally focused about design, and for us is important. Two things are important: both creativity and execution. So creativity is about innovation, but it's important that the things that are designed using our tools also are successful in the marketplace. Any type of complexity needs to be supported, and we take pride when the companies are successful in doing so. The design itself is not sufficient anymore, and we have been doing this for the last 26 years actually. This year we will release the 25th version of SolidWorks, and so we have been doing this for many years, and this is not changing. We are still very much focused on design, but the world is changing. The meaning of design is changing, and people require more flexibility, more performance. People today work connected. There is a shift in devices from desktop to mobile, and indeed the pace of innovation is accelerating. If you think about what it took in the last couple of centuries, for instance, the telephone technology to be adopted by 1/4 of the US population, it took 35 years. Now, fast forward in the 2000s, it took 5 years for 1/4 of the US population to adopt social networks. So this means that whenever you innovate, that innovation is consumed at the speed of light. And of course, the internet has a big role in that. And it went from connected devices to connecting people, from connecting PCs, it went to connecting people, and now connecting everything. And we need to be up to that challenge. It needs to be reflected in the tools that we do. So I would like to now shift into what we call the product strategy. So what do we do to stay ahead of the curve? What is coming up? What is the future? And we have fundamentally 3 pillars, 3 directions we are working on. And we are putting together a very large portfolio of solutions that we call the platform for innovation. We are working on desktop solutions, the ones that you probably are using today, every day. So things that require evidently a desktop, that require an installation, and that have been refined in the last 20 years, and they have still way to go. However, as I said, the world is changing, and people demand instant ability to be productive, and even avoid the nuisance of installation and upgrades. That's why we are devoting a lot of time into creating both the connectivity of our desktop portfolio, but also we are going into the direction of a full online lineage of products. Online meaning that they run in a browser, exclusively in a browser. So you don't need to install anything, and every upgrade, any storage, any backup, any tools dedicated to collaboration, all of this happens in the cloud, on a server, happens away from your device. This means that you have a much larger flexibility to connect to your intellectual property, to your designs, and to your projects anywhere, anytime, using any device, because the central storage is in the cloud, is not on the device that you are using at any given moment. And so in this direction, we are working on many, as I call it, innovation streams. And we have a growing and large portfolio, and we don't have a lot of time to go in the details of each and any of them. But I would like to focus on a few of these innovation streams that are influencing both the desktop and the cloud lineage of our products. Let's start with what I call, and these streams in particular today I want to talk about 3 streams. One is the connected mechatronics, One is production digitalization, that I think is very fitting to the mission of the CBI, because this idea, this dream of going from bit to atoms and vice versa is something that inspired us profoundly, and this is the reason why we are working on a very long collaboration with Neil and the team, and it is what's coming out is very inspiring and very interesting, and it's basically the future of fabrication, because at the end of the story we spend a lot of time on design, but if you cannot fabricate, any design is meaningless, and this is going to be fully integrated. So I will spend some time on what this means for us, and then new design paradigm, so something that we are working on today, but we think is going to be the future of design as well. For connected mechatronics, I think it is important for you to know that we have a new product called SolidWorks PCB that we did in partnership with Altium. PCB is printed circuit boards. Today, any mechanical engineer needs to be versed on multiple disciplines. Every mechanical engineer is in reality a mechatronic designer that needs to know about electricity, needs to know about electronics. As a matter of fact, we try in the Fab Lab. You have electronic circuit boards fabrication tools. We tried, I have to admit, unsuccessfully to create a sensor with a small printed circuit board, and probably my welding skills were not that high at that time, but I'm working on it. But anyway, so the good part of this is that people using our platform will have, starting from actually this month, a new tool called printed circuit boards, and will give them the ability to design electronics in a totally integrated way with SolidWorks. So this is what we do. Our platform is always fully integrated. In this case, there is bidirectional collaboration and synchronization between Altium, actually called the SolidWorks PCB, and the SolidWorks design itself. And I would like to offer you a very simple example. So this is a circuit board imported into SolidWorks, into the CAD design. Here I change a dimension, and then with the click of a button, actually inside a panel that is directly into SolidWorks, I communicate the design change to Altium. Altium now can import my design and highlight the change that I made. So basically a narrower circuit board, a narrower footprint for the circuit board. And this is instantly merged with the electronics design. So the electronic designer can move around the components in order to satisfy the new space requirements. I am told that this is what happens over and over again when you create smart devices, where electronics, where the form, the shape of the device is optimized, has many constraints, and the electronics design needs to satisfy those constraints and to simulate that everything is in order to work seamlessly. This is very important in connected objects, right? So the famous Internet of Things, which is one of the evolutions of the trends that we are watching very closely. Today, if you go at CES, actually CES this year, most of the highly prized products, especially consumer products out there, were designed in SolidWorks. Halo, for instance, they got an innovation award at the CES. Is a tool, is yet another smoke detectors designed using SolidWorks and, by the way, Altium. And there are many other examples. So for us, it's important to go from design to connection, to connectivity, to connecting any device, and analyze and automate the working of these devices. And we are putting together, as I speak, we will be able to launch this solution at the next SolidWorks World. We are working for an integrated solution to make it possible to connect any devices. And we are doing it with a company here in Boston called Xively. We are partnering with them. They are specialized in connectivity. In basically, they understand all the challenges of connecting on any type of latency devices of any type. In fact, this is the same company that creates software for connecting PC remotely. So they have a lot of experience, a lot of assets, and we are partnering with them. In addition to that, once you have connected an object and once you are able to detect and collect signals, then you need to analyze those signals, and then you need to operate remotely your devices. And for that, in addition to Xively, we have in the Dassault System other brands that are specialized in big data, in analyzing and automating remote devices, and these are called Exalead and NetVibes. And we will be showing this type of solution very soon. As a matter of fact, some of our customers are already using a combination of this tool to do their innovations. And I would like to show one of my favorite to you. Is a small video of a company called Freight Farms. It's here. I don't think there is any voice, so I will comment on it. This is yet another startup here in Boston, and their idea is very simple. They wanted to make a small farm in freight containers, and this is exactly what they do. So this is a freight container. This is a small ecosystem that has everything that is needed, is hydroponic, everything that is needed to grow produce or other types of products, and is very clean. There is no soil, it's only water, temperature, and light, and can be remotely controlled. This was done in collaboration with Xively. So the story here is that we are looking into novel ways to develop our society, right? And the micro farms basically bringing the chance of producing the food that you eat close to where it is consumed is something that fascinates us very much. And this company is doing exactly that. Now, the next topic is product digitalization. Now, again, this is the future of fabrication. The future of fabrication is to go from bits, from digital to atoms seamlessly. And there are many ways, many ideas, a lot of work. The most advanced research is happening at CBI for sure. And what we are doing also on the desktop lineage of products is to adopt the so-called model-based definition standard, which allows machines to understand manufacturing details. So let me show you an example. Here we have to manufacture a little bracket with 1/100th of inch type of precision, of tolerance. And here this partner of ours called CamWorks was able to devise a simple drilling operation to do that. With the type of tolerance, it is indeed possible. But the problem is, what do you do if you change the tolerance to 1/1000th of an inch? Now, a simple drilling operation will not get you there. So the fact that there is a standard means that a robot can read that new tolerance and can make autonomous decision on the type of manufacturing cycle. In this case, from a simple drilling, the machine has decided to go to a combination of drill, ream, and bore, which is the type of manufacturing cycle that is necessary for you to achieve this type of precision. Again, this happens without any human intervention. Another big benefit of adopting the model-based definition in our desktop lineage is the capability to automate the quality control. In this case, a robot can understand where are the deviations, can fully create what is called a Title I report in a totally automated fashion. In a previous frame, you might have seen the heat map of the deviations. So it's very visual as well, but again, this is done in a totally automated way. Another area where we are working is to partner with our many robot manufacturers to bring the programming of robots to the next level, and again realize a seamless continuity between what is designed and what is necessary to automate the manufacturing, the fabrication. In this case, the handling or the welding of the products. So today, these robots are designed in SolidWorks. Today, the work pieces, the products that needs to be welded are designed in SolidWorks as well. And the welding operation, we have specialized features for that. So it only comes natural, even complexity like this, it only comes natural to create a total automatic way to go from the design to the programming of these robots. Now, this is a very high-level type of capability because, as it was evident at the beginning of the video, you have to coordinate multiple robotic arms running very, very quickly, working simultaneously, up to 11 axes of rotation. So this is very difficult to achieve with manual programming. And today, the state of the art of many robots is to program them by teaching, which is very time-consuming, can be dangerous, and is also not very precise. So this is another theme we are working on in the stream of product digitalization. Let me move on to my favorite topic, which is the introduction of new design paradigms. So, what will mean design in a very close, in a very near future, in my opinion? So, first of all, we have already introduced products for industrial design, and this means that all the paradigms like pen and tablet, pen and paper, are still very much useful, and we have decided to innovate by fully embracing this type of old-fashioned design paradigm. And as you can see, and there are many industrial designers that are very comfortable with the stroke of a pen. It's a very nice way to communicate ideas. But the innovation here goes from a casual stroke to a more precise type of mathematics that can be used to derive 3D shapes. And I will show you how here. So here again is done with a stroke of a pen. It's a tablet, it's a Wacom tablet, but it can work also on the new iPads. And now comes the interesting part where you can adapt in a clay-like fashion that is very far from the sketch and extrude approach, a feature-based approach. As a matter of fact, this is, as you can see, is a mouse. And our idea is that it is possible to design the entire mouse by using just one feature and simply manipulating the shape using, again, a combination of pen-based strokes with a precise manipulation using a triad. We call it the robot. We have, of course, the possibility to do symmetrical changes, asymmetrical changes as well. And all you can see here is class A natural. So this is a technology called subdivision surfaces that is instantly traduced into traditional NURBS with a class A type of continuity. So the shape is very beautiful, and the reflection lines are very natural, as you can see. In addition to that, of course, this is all based on our platform, and our platform is designed for collaboration across any devices. So you can see your design across a multitude of devices just by connecting. The other thing is that it is possible to sketch directly in 3D. What you see is a simple stroke of a pen happens directly in 3D, and it is very, very natural. And as well, these curves can be translated into precise geometry and used for the design itself. And of course, now here is, you see the platform where we can share, where we can have discussion, where we can have some kind of online conversation similar. This is what we call the Facebook for engineers. Now, this is for what concerns industrial design. Now, we have also a new category of apps coming up, and the one I would like to talk now is called X Design. We are going into beta phase right now, and we believe we will release to general public by the end of the year. And this is a new category of apps that is designed to run entirely into a browser. As I told you at the beginning, this is one direction that we are very intensely pursuing. But this is not simply moving all the SolidWorks capabilities into the browser. This is not enough. I mean, if somebody needs to have SolidWorks capabilities, there is a very powerful product already out there. This is what I call trying to put the attention on the A of computer-aided design. And arguably, we can say that the feature-based approach is a kind of cut and paste, okay? So designers design shapes based on their experience. They tell the computer what they think. The computer is aiding you, making it very easy to change, modify things, store them, do analysis, and so on. But the computer is not helping you very much for what concerns the type of shapes that you need to perform a similar, a given function. Now, we have decided to change this paradigm, and we wanted the computer to tell you in the first place how the shape should look like in order to perform a given function. And I want to show you an example. So let's try to look into a very demanding design challenge, which is the rear fork of a motorbike. Rear fork of a motorbike, especially for competition type of motorbikes, has to be very stiff, but has to be very light. And the shapes change widely. So the question is, what is the optimal shape? What is the best shape? And the thing is, why don't we ask the computer to tell us using technologies like topology optimization? Let me show you how. So here is a mock-up where we have the part of the frame that connects to the rear wheel. And here we wanted to simply tell the computer what are my design constraints. So in this case, there are the connections to the frame, those two cylinders, and then there is the rear wheel, where the force is applied. And then I just input a few parameters, like some parameters like the field target, the volume where I want my my shape to be constrained, and also I am indicating to the computer what are the keep out volumes here. Of course, I don't want my rear fork to interact with the wheel or with the chain. And then I just click a button, say, give me the shape. And here is what the computer is coming up with. Analyzing your input, which is force and constraints, and then optimizing and refining the solution. This is, we call it a voxel type of technology, topology optimization voxel-based, because as you can see, it's very much pixelated. But you can work with parameters to smooth this shape, and then, interestingly, you can easily get to a shape that is what the computer thinks is optimal to perform this given function. It is interesting because the computer has decided to go on one side only. And the single fork, the single arm fork, is today, by the way, the state of the art. And the computer knew it even before me telling it. So, as you can see, the shape, by the way, you could go and 3D print it directly. Now, it's probably not perfect from an aesthetic point of view, but it tells you exactly where material should go and what are the size that will give you the strength and the stiffness that is necessary. And it is surprisingly close to many designs of competition motorcycles that have been refined after years and years of experience. And the computer came up with a similar shape just in a few minutes. Now, other things we're working on is to expand our reach into education, that I told you is for us very much strategic. And we are working very hard to bring the wonders of design and fabrication to the kids. And we have designed special applications that are very appealing to kids, very super easy to use. They run in the browser, very low server overhead, so most of the computations happen in the browser, in the JavaScript code. And why did we do this? Because, of course, this application needs to be very, very cheap. And of course, the load on the server cannot be too high, otherwise the cost go up. Let me show you what we came up with. So this is the same subdivision technology that you have seen at work in the design of the mouse, of the computer mouse. This is a simplified version. There is no translation into NURBS here, so the precision is hardly detectable, but is not very high, but is good enough for the kids. And then you can paint. You can paint it directly on 3D, same technology that we've seen before for the higher-end industrial designer. And you can also take snapshot of your environment and make it your stage for your simple animations. So this is a truly 3D object, and it can also be 3D printed. But we don't want to stop to shapes. We also are working on introducing gradually to the kids all the disciplines of engineering. And the next one is motion analysis and kinematics analysis. So let me show you this. This is a design for the iPad. Just with a finger, you can create links, and you can attach motors very, very easily. And then with the click of a button, you can create some kind of spirograph, so a device that can trace the trajectory. So as you can see, in a very few seconds, kids are exposed to very interesting and very high-level concepts. The idea is to attract them to the wonders of engineering and science. So this is the end of my presentation. Thank you very much for your patience. And my conclusion here is that today more than half of the humanity lives in cities, and our ultimate goal for us and for our company is to harmonize product, life, and nature through the innovation of science and technology. So we believe that not only better products, but also products that are more relevant, useful, and optimize the use of natural resources is what people need, and we are interested in being part of the story. So thank you very much for your attention.
That's great. Thank you, Gianpaolo. That's a great tour through that arc. Let's open up for questions through the chat. And let me start with a few. So the last recitation was James Coleman, a student from MIT who's now at Zahner, working on Zahner's huge buildings. And he explained they have to go to CATIA to handle the complexity of like one of Frank Gehry's buildings. That's the only thing that was holding up for them. Can you talk about the relationship between SolidWorks and CATIA, both as part of Dassault?
Yeah. So what I call the new lineage of products that are happening in the browser, the X type of generation, X design, where we design the rear fork of the motorcycle, they are all based on Dassault Systèmes core technology. So for modeling is based on the CGM modeler, which is the heart of CATIA. For constraints is based on the CDS constraint solver, which is at the heart of CATIA. The optimization technology is based on Tosca, which is part of the CATIA portfolio. So the future is basically means for us much more integrations in terms of the technologies that we can use to innovate in SolidWorks. As you know, in Dassault Systèmes we have 14,000 people, almost 5,000 working research and development. So what we call the war chest or the playground is very large. Now the difference is that CATIA is and will be focused on application in aerospace and automotive, where they are very well known, and they can extend into a certain type of complexity. And our specialization at SolidWorks is to make it possible to solve very difficult problems, but with tools that are as easy as possible to use. This is part of our DNA. So our job now is to take very advanced technologies, to simplify, put the right user interface, and to make them usable to millions of people that don't have a lot of time to spend into learning details or being taught how to use a tool. The tools need to be very natural and intuitive.
So I wanted to pick up on that. After the wonderful time we spent in Kigali, I enjoyed earlier to go to SolidWorks World, which was 10,000 people. So I want to ask you about 2 factors of 10 to the 3. If you think about what we did in Kigali, if you go from 10,000 people at SolidWorks World to 10 million people using it, and then 10 billion people using it, the vision is everybody becomes an engineer. So talk about those two steps of 10 to the 3. What has to change in the software and what has to change in the business for those to scale?
Okay, you are the specialist, and you are the one that is inspiring us to pursue this vision. You're right. I mean, why not 10 billion people? And the direction is basically we have to dramatically lower the barriers of access. We have to dramatically lower the cost and the accessibility. So these tools need to work on any type of devices, and we are working on it only. And it's also the art of our collaborations, the idea that things need to run in a browser. And it has to be sustainable also for us as a company. So there must be a business ecosystem around it, but we'll be more focused on the services. So the fundamental technologies, the fundamental capabilities of designing needs to go in the hands of everybody in the world. So like today, the capability of research needs to be open, to be able to create business model on top of it. And we are aiming at the similar trajectory. So the capability of creating designs has to be available and open to as many people as possible, so that people themselves can open up their mind to create business model on top of it, creating services, creating added value capabilities that have a tangible value and deserves to be paid off. But when we have this type of numbers, think about billion of people designing, likewise there are billion of people doing searching for things, then the economy of scale becomes affordable and becomes meaningful for any companies that is involved in this.
Okay, good. I wanted to underscore a couple of things Paolo said for everybody listening that are going to be coming. One is the Altium integration. So being able to do advanced electronics design merging with SolidWorks is coming in the not too distant future, is an important capability. One is the web capability, so you don't have to install anything. One is the optimization tools, so you do declarative rather than imperative design. You say what you want, not how to make it, or all things coming. And one exciting collaboration is we expect to be working very closely on integrating this whole software ecosystem with all the software development in the Fab Lab network to make a permeable boundary. So you can go from the SolidWorks world into the Fab machines, and from the Fab machines back into the SolidWorks world. They're all parts of the collaboration coming, I wanted to underscore. Looking at questions starting to come in, Zuberi from Detroit is asking about science and art teachers. Do you have teachers starting to use the tools with the kids?
Yes, the apps for kids is now in beta phase, and we are starting a public beta in July, meaning that everybody can participate. As a matter of fact, if you are interested, let me there is a website, or you just search up for kids. I'm scrambling now to find out. Anyway, so if you search for SolidWorks app for kids, probably it will pop up. Yeah. So basically, app4kids.solidworks.com, you can see there, and there is a way to participate to the beta phase. Yeah, we are working with 30,000 educational institutions, mostly higher level of education, so universities and colleges, also high school. We want to extend it to everywhere. We also have an important partnership with a company called Sindo, that creates entry-level printers of very high quality, basically sub $1,000, and we are interested in creating some kind of bundle and offer for schools of any type to basically introduce the kids to the wonders of fabrication, digital fabrication.
And that's a good lead in. The recitation next week is with two leaders in K-12 education, Sylvia Martinez, who's associated with Maker Education, and Sherry Lassiter are going to be talking about K-12 Maker Education. Tomas, did you want to ask anything?
Yeah, I really like your final statement, Gianpaolo. Well, first of all, thank you for the recitation, but I was really interested on the final statement that you were making about how we need to make cities more productive and sustainable in terms of the resources they have. And we're running a program in the Fab Lab network that is called the Fab City, which is exactly looking to that. And I have a question related
Sorry,
to...
let me just interrupt to bridge between you two. So, Gianpaolo, at Fab 10, Barcelona's mayor famously pushed the button for the 40-year countdown to urban self-sufficiency. And the idea of that is the bits come and go freely, but the atoms stay. Barcelona can produce what it consumes. And that means energy, food, everything. At Fab 11, a number of other cities, including Boston, Somerville, Cambridge, joined it. And at that time, the architect of Barcelona was Vicente Gallart, who started the Fab Lab in Barcelona. And Tomas is now point in helping run up this Fab City program. So we have a growing group of cities, not as intangible, but as really tangible, committing to this 40-year countdown with the initial goal of 1% in 1 year, sustainably, locally producing what they used to source from a distance. So Tomas is really kind of accountable for helping cities deliver on creating what they consume, as background to his question.
Yeah, and that basically comes into a very practical level. We're trying to connect the cities with the local Fab Labs. So my question would be is if you have any plans to embed tools in the design that allows you to understand the environmental implications of a selection of materials, supply chains, even, I don't know, in processes. So it would be interesting to see how my design affects the world.
Yeah, actually, thank you for the question. We have, we not only have plans, but we were the first in the industry to introduce 5 years ago tools for sustainability and for costing. So you can also compute the carbon footprint, for instance, of the processes related with the materials that you choose. So it is already part of SolidWorks. It's called sustainability and costing, and we are constantly improving upon it. But the other things that I would like to mention here refer to the cities is the initiative that our umbrella company, the Dassault, the group, is undertaking as we speak. It's called the 3D Experience City. As we speak, the Dassault ambition is to model every bit in an entire city, and is now working with the city of Singapore to digitalize the entire town. Not only the buildings, okay, but also the people, but also the equipment, the energy, the nature and the environment that surrounds it. So Dassault has this ambition to create digital twins. Basically, they correspond the bits, to create the bits in order for the atoms to be optimized according to the bits. Because with the bits come and go, as Neil said, but the atoms are here to stay. So we need to make a conscious decision on how two atoms are put together for the benefit of everything, to create a better environment. So you'd better make a conscious decision. You'd better simulate many times over, and every time you decide to move or to put a new atom in a city. And the digitalization is part of it. Now, Zanner, the architect, was mentioned before. Zanner architect, that they use tools in our platform to design very complex buildings. But there is another interesting project happening in Los Angeles, which is the redesign of an entire ecosystem of 10 miles of the river that flows through the Los Angeles River. And this is right now being considered by Frank Gehry. So I visited the lab, the Frank Gehry studio, and they told me that the problem number one for those type of projects is exactly to figure out what we are dealing with. Where are the bits? Because today the 10 miles of river are like a yard-high pile of drawings that most of them are obsolete, 2D, maybe geological survey or maps or whatever, and it's almost impossible to have a comprehensive view of the problem to solve. That's why it is so important to have the bits before we decide on the atoms at the city scale level.
I'm eager to connect between you two because Tomas, Vicente, and I have done a lot with smart cities. And smart cities almost always assume you can't go from bits to atoms or back again, meaning there's the bit world and the atom world, but you can't turn one into the other. And the distinction in like Fab City versus Smart City is bits can become atoms and atoms can become bits. And it's a really different set of skills once you mix digital fabrication and digital scanning, exactly to your point. So you can scan the city and turn it into data, but you can also fabricate the data. Hasn't been part of the smart city discussion to date, and that's the real killer app. That's the real opportunity to change the world. In many ways, for me, that's the realization of the whole Fab Lab vision, is being able to, self-sufficient production. Tomas, you're nodding?
Yeah, I could not agree more. And it would be nice to find out how we can connect more the Fab City program, because we're looking also to understand all the cities participating globally. They can actually see which are the bits that come in and out, which is another piece, no? What the city imports, what it exports, which is the other part that would be interesting.
Can you briefly recap what happened in Amsterdam with the EU and Fab Cities?
Yeah, Amsterdam holds the Netherlands, the presidency of the European Union, and they basically have a 6-month cultural program and meetings in Amsterdam, and they basically take 8,000 square meter island called the Java Island and created the Fab City campus. So it's a prototype of a future of living where houses produces all the resources that they need with urban farming and many of the topics that we're talking here. So we organized a meeting an expert meeting of 40 people from Europe to discuss the different steps looking forward to create this locally productive and globally connected self-sufficient cities program, which is the Fab City. And the city of Amsterdam, through its deputy mayor in culture and economy, officially signed off press the button for the Fab City program.
Very, very interesting. I think Bernard would love to hear the story, Neil. He's in Boston. I don't know how long he's staying. I see if he can come to the MIT to see you.
I'm in town Monday through Wednesday. For everybody else, we're talking about Bernard Charles, the CEO of the Parent Dassault company, who's really passionate about this inversion of like turning everybody into a designer and engineer for the future of the world. Let's see, I have a technical question, which is, in the Fab Academy, we do a lot of CAD, CAM, and fabrication, but there's also a lot of programming, like writing microcode and mixed signal systems. Do you have a vision for how software relates to hardware? Right now, you don't program. You might program the use of SolidWorks, but you don't use SolidWorks to program. When you make a mixed signal system that mixes code in the design with code in the execution, do you have a vision for that?
Well, yeah, I have some ideas. You're right. We program SolidWorks, but arguably SolidWorks doesn't program the fabrication world. And I think the beginning is, first of all, to make sure that what the designer creates encode the signals and the information that then can be used by a program, also a partner, but not necessarily us, but anybody else to go read the mind of the designer in the bits that are represented by SolidWorks to create to program the machine. That's one thing. The other is for the robotics. So the idea for me is to my vision, my desire is to make SolidWorks a platform for the programming of robots. Robots is a fast-growing field. It's very demanding, and today design systems are not set up to be programming stations for robots because the complexity is very high. the precision that is necessary changes. It depends. For instance, when you are working, when you have multiple arms working together, collision detection doesn't need to be precise to the millimeter, right? But needs to be very, very, very fast. And today we have collision detection tools, technologies, but they're not ready yet for the type of capability. Our kinematic simulation is not yet up to 11 axes of rotation. So we are equipping SolidWorks to become a platform in order to program manipulating and fabricating robots. This is what I'm trying to do, and also to make sure that the digital information fully embed everything that is necessary to fabricate something. For instance,
so let me just note, we're almost out of time. So if you have any final questions for Gianpaolo, please send them through the chat. Your answer raises a question, which is most people use SolidWorks out, but not in, meaning you don't try to bring real-time data into it. Talk about that piece, about bringing sensor data into the SolidWorks world to interface.
Okay, that's a very good point. So actually, this is part of our collaboration with Cybele. So they are very, very, very smart in processing data. So our dream to create connected objects is exactly this. So to have the ability to drag and drop sensors, for instance, and then to simulate digitally what happens when those sensors react to whatever they need to measure, and also to immediately create the software to benefit of the signals and to manipulate the design itself. So yeah, this is part of the story of a connected object. So you drag and drop sensors, you can design the circuit boards to control the sensors, and then you can really simulate the signal and see what happens when it is connected to a remote device, and when you click a button on the remote device. So you send another signal, like what happens? Does the door open? And you can simulate the door opening. We are kind of working to make this happen in two directions. One is the full automation, basically being able to get the data in to program robots, but this is not signals, rather design information, the workpiece and the robot itself, and then coming out with the program. And the other one is to have a full digital experience of connected objects by this time instead getting in the signal and processing digitally the signal and reacting accordingly to see exactly on the screen what would happen in reality. So the dream is on the click of a button, really, literally, being able to create a connected device and simulate it in real time, and then fabricate it, because we already have everything. We have the PCB, we have the plastics, okay, and we also have the software to control the sensors that can be downloaded into the microchip that goes into the circuit board. This is what we are doing with Cybele, and this is the story that we want to bring. Keep it for yourself, it's a secret, to SolidWorks World 2017.
Yeah, I think it's really exciting because there's a fundamental sort of disconnect. We teach software as lines of code, but it executes as a physical system with geometry. And for me, software is geometry. And so I think there's a real opportunity to like fundamentally revisit the foundations of how you describe automation, not as lines of code, but as geometrical structures that perform. And so I think representing computing in SolidWorks isn't a little thing. It's a really profound change in the history of compute, in how we think about, computing.
Yeah, totally agree.
Good. We're down to
just make it geometry speak.
Yeah. Any final questions or comments on any side? We're almost out of time.
Not from my end.
Okay.
That's been great.
Yeah, I think it's great to do, coming from this, linking the Dassault Smart City thing with the Fab City would be a great outcome from the session to breach the bit atom boundary. So smart cities can turn data into things, not just describe things.
Yeah, that's a good catch line.
Good. Well, great. That's a great roadmap. Look forward to collaborating on it. Thank you for the hour to tell the story.
Thank you, everybody. Thank you for your attention.
Thank you, Gianpaolo.
Thank you.
Okay.
Bye-bye.
Bye bye, everyone.